Farmers all over the world are incredibly busy people juggling a lot of different things and really managing a lot of different risks all at one time. Where we really need to shift focus is on that end user driven technology development piece. Also really excited about all of the new satellite constellations that are being launched.
We are working very hard to bring all of those new constellations and all of those new sensors into the platform and make them more available to people to solve real world problems. So that's great. Hi, everyone, and welcome to another edition of Looking Up with UP42. My name is Sean Beats, and I am the CEO of UP42. For those of you who are new to the series, UP42 is a open geospatial marketplace and a developer platform. We've been created with the goal of helping people to access geospatial data, remote sensing data, and insights from this data at scale. So with me today, I have Dr. Keely Roth. Dr. Keely Roth is a data science manager at the Climate Corporation. And the Climate Corporation is an organization based out of San Francisco that's helping farmers on a global basis to improve their yields by the application of technology and data science. At Climate, Keely is leading a team of data scientists, really working on the problem of algorithms, data quality, how to make sure you can help farmers improve yields and build this sort of upstream algorithmic capability to detect, identify, and correct data quality issues. So, hi, Keely. Thanks for joining us. Thanks for joining us today.
Thanks for having me. Excited to be here.
So, Keely, look, I've given a very short introduction to the Climate Corporation and to what you're doing there, but I'm sure I haven't done it enough justice. So maybe you can tell us a bit more about the Climate Corporation.
Sure. So Climate Corporation is really focused on delivering digital solutions that help growers manage their risk and drive enhanced farm productivity. The way that we do this is really through kind of three pillars. One is helping our customers, our growers, get all of their data in one place. Then we help them organize that data, visualize it, start to gain some insights from it, really sort of empowering them to use the data that they collect. But we also bring in other outside data streams, things like weather data, things like satellite data, airborne UAS imagery, and we start to build those on the back end into agronomic data science models that can be integrated back into our field use software to really help farmers make better management decisions on their farms.
Thank you, Keely. And so tell me a little bit more about your role. I mean, there's there's a lot of different versions of what data science means to different people. So I'm very interested to learn more about exactly what you and your team are working on.
I began with Climate Corporation about 5 years ago, and I started as a remote sensing scientist. My background is really in using imagery, particularly hyperspectral imagery, for measuring and mapping plant health and function. And so when I started at Climate, a lot of the projects that I worked on were around using satellite imagery to monitor crop health in season. Since then, I've had the opportunity to move to a couple of different roles. I led our exploratory research program in horticulture and vegetable crops for a little while, really looking at how we could extend some of the science we've developed in broadacre row crops over to smaller acre specialty crops. And now I have a really, really cool position leading one of our data quality teams. Specifically, we work a lot with the machine data, or the data that's collected on the different farm implements by our customers that they upload into their field view accounts. And a lot of the data science we do is what you might consider behind the scenes work to really evaluate, decorate, and enrich that machine data in order for us to make the most use of it in our downstream data science models.
It sounds really interesting. I mean, it's one thing that I've certainly grown to appreciate over the years is that, unless you have a proper strategy around maintaining data quality and keeping constant tabs on that data quality, you're not going to get the best use out of it. So it's certainly very important. One question I had around the use of remote sensing in agriculture in general. This has been seen as a very tough vertical market for geospatial companies to enter, and I certainly have come across it many times where there's been a sort of skepticism between like the effort and the cost versus the actual benefits, and at what scale does it actually start to really pay off? So can you talk a little bit about how this has changed over the last few years and how maybe the Climate Corporation has overcome some of these early challenges?
Sure. I think as with any technology, it's very easy to build a lot of excitement and momentum about what could be. And the challenge then becomes to connect that to what actually is and what you're able to build from that position. In remote sensing and agriculture, I think a lot of the challenge came from excitement over just creating a map and delivering that map to a farmer, to a customer, without any of the domain knowledge or expertise needed to interpret that map, and often without really connecting it to the problem that the customer is trying to solve. So while it is, I think, a really great tool for building a bridge to other technologies, I can give an example of that. Think of a grower who is maybe interested in using variable rate equipment or spraying one part of the field and not another part of the field. Oftentimes, if they're able to look back through historical satellite imagery and see a management difference show up in remote sensing imagery, it really helps them understand what they might gain, right? It verifies at a field level or an operation level something that they experience themselves on the ground. So that's one way I think in which climate has really helped start to bridge that gap over the skepticism around the usefulness of imagery. The key is to not stop there and to really focus on what are the new technologies that can really address the problems an individual grower has. Is that really early detection of disease? Is it coordinating operational logistics for in-field scouting? Is it looking at how much of a crop area was damaged in order to make an insurance claim more straightforward? So I think the goal here is really to use imagery in a way that solves a specific problem.
I think this is a really important observation. It's one that we've seen over and over again in the work that we're doing. First, generally, and also very specifically in the agriculture space as well. So UP42 being a horizontal platform, we see ourselves as an enabler, providing access to generically to the data, to sort of algorithms that are available off the shelf, and a platform that can process the data at scale. But we're not the ones that are necessarily solving that very specific end user problem. And that's where we're very excited to work with a range of different companies that are actually stepping in and solving that last mile, that last very customer specific problem that has that real value attached to it. And specifically in agriculture, we've been working together with GIZ and Airbus and Make IT for Africa and CC Hub Nigeria on the Africa for Future program, where we've been basically doing capacity development in agri-tech startups in Africa. And this has been a common thread, the translation of the generic imagery, the generic mapping capabilities into concrete field level use cases for yield prediction to enable farmers to get credit or to crowdfund farming activities on a very small scale. So this is a really important thing to watch out for. It's actually a good segue though into my next question, which is, we've spoken about massive amounts of data on large scale farms from farming equipment, etc. And I've spoken about smallhold farming in Africa. And I think this is one of the big challenges, that serving the agriculture sector means very different things in terms of different parts of the world, different kinds of crops, different kinds of scale of massive scale commercial activity versus small scale farming, smallholder farming in some countries. So how do you think that this plays into how the Climate Corporation is approaching solving some of these problems?
It's an excellent question. So the software that we produce, Climate Field View, is really not a size limited software. And I would say that it has two pieces to it. One is sort of easy access to data, and the other is the collection aspect. And I think no matter what size farm you're operating, and no matter how that farm is managed, whether you're someone who is renting land or you have just your own small plots, or you're growing some incredibly large, tens of thousands of acres operation, you're going to want to collect information about that. You're making management decisions, and having a place where you can easily track that, along with other very relevant information like weather, agronomic practice information. So I think one of the key pieces of how FieldView can be helping farmers of all sizes is really putting that tool set into their hands to help them work with the data they have and bring data that they might otherwise not have access to into their hands.
So an extension to that question, thank you for that. But an extension to that question is obviously like the level of technological capability or implementation, or the level to which technology is used in different farming practices is also very different. How does that impact how you've built your product? So not only from a scalability perspective and how big is my field perspective, but really in terms of the technological level of the farmers themselves.
We think probably about this in two ways. One is that like front end user experience. So what kind of device is someone working on? Are they sitting down in an office behind a desktop computer, or are they just working on an Android phone out in the field? Do they have an iPad? And so a lot of that actually becomes about good software design and good UI design, which maybe the furthest thing from people's mind when thinking about using technology to really help and empower farmers. But it's critical. You need to have a software interface that helps people use your software effectively while they're doing their job, while they're making those decisions. Farmers all over the world are incredibly busy people, juggling a lot of different things and really managing a lot of different risks all at one time. And so having a software that can help support them is as much about getting the right access to that technology, and being able to enable them to interact with the software as it is in thinking about what kind of technologies do they use on their farm. On that side of the coin, we're really talking about how is someone managing their farm? Are they planting by hand? Are they using the newest, shiniest equipment manufacturer's planter? And there, I think it's a lot more about building tools that really work at any scale and thinking about different ways of capturing the same type of data. I think field boundary is a really good example of this. You can imagine deriving a field boundary from a planter's GPS pattern, right? Like auto deriving that boundary based on where a grower planted. Now, someone who is a smallholder farmer, they might derive their field boundary just by looking at a satellite image and putting in four corners of a plot. And so you really want to think about what's the information you're trying to help a grower capture and making sure they have the tool set to capture that no matter what sort of technology they're working with.
It's a really nice point you make about the software design itself and the user experience. I've been involved with GIS and geospatial now for more than 20 years, and one thing that's always bugged me is that we're working with some of the most like high potential visual experiences that you can imagine with satellite imagery and maps, and yet often there's a lot of, or there's not enough attention actually paid to the user experience overall. Thankfully, this is changing, and there's a lot of good examples of going in the right direction today. But it's always been something that's bugged me, and that's something we're certainly trying to get a grip on UP42 side as well. So in general, like, how do you feel about the geospatial industry and the job that we're doing to help develop technologies for growers and for farmers? Like, what do you think we as an industry can do better?
Sean, I think we touched on it a little bit already, and I would just bring us back to it. It's really easy to get excited about all the new sensors, all of the like increasing volume of data, all of this information. And I would put a question mark on the information because we want it to be information. We know it's data. We know we're getting more of it. More has to be better, right? But I think if where we really need to shift focus is on that end user driven technology development piece. And that's in a lot of ways, I think building a better customer in the loop to our development of these technologies, really thinking upfront about the problem sets we're trying to solve and how we're going to test those solutions with customers. I see a lot of really great science and really great technology development out there that sort of really waits to get it into the hands of consumers, and then is often, has that aha moment when something very simple, like stands in the way of a customer really getting the value from what you've built. And so I think really just continuing to drive for that end user driven remote sensing approach and pulling customers and stakeholders into those early development conversations in order to make sure that the technology is actually going to do the job that we want it to do.
Thank you for that. So you mentioned some geospatial developments. Maybe we can end on the last question from my side. So from your perspective, what are the most exciting trends and developments that you see that have either just arrived or are in progress over the next couple of years?
Yeah, I mean, despite what I just said, I do get excited about the technology. I think some of the advances that are happening in the drone space are going to continue, especially in agriculture, to become more and more a part of the picture. In particular, I think we're going to see expanded freedom to operate in that space, which is also going to be coupled with a lot of the edge compute capabilities that are being developed there that really allow us to push algorithms onto platforms. And you can imagine that becoming very powerful from a precision agriculture perspective, being able to detect and manage crop health issues on a very, very finite, very focused scale. And I think that's really going to change a lot of how farmers think about managing their fields if they're continuing to gain access to that tool set. Also really excited about all of the new satellite constellations that are being launched. I think that one of the things that's always sort of been a major factor on the remote sensing side when you're thinking about developing algorithms or developing models to translate imagery into meaningful maps has been having the right sensor, being able to get data at the right cadence, being able to get data at the right spatial resolution, being able to have the spectral bands that you'd like, or have even just the part of the electromagnetic spectrum, the signal that you want to measure. And seeing all of these both passive and active satellite constellations be launched, and really the continued improvement in quality of those constellations is, I think, really opening up the door for a lot of the remote sensing science that's already been developed to actually be used in the real world, right? To move it out of the academic realm and into practice.
That's great. I couldn't have imagined a better way to end that. I mean, this is exactly what we're focused on UP42. We are working very hard to bring all of those new constellations and all of those new sensors into the platform and make them more available to people to solve real world problems. So that's great. Okay, so thank you very much, Keely, for the discussion. We've spoken about the Climate Corporation, your work there, working on data quality and making sure that you're able to derive the most out of the data to help growers. We've spoken about challenges in the industry related to good user interface design, making sure that we're focusing on end user problems as opposed to just the technology. And we've spoken about some of the upcoming trends which are going to help us to unlock the downstream potential of remote sensing and Earth observation in the future. So maybe some final thoughts from your side, Keely?
Yeah, I guess I would say, whether you're focused in agriculture, you're focused in conservation, you're focused in some other place where you're trying to really use geospatial technologies and imagery to change the way that we're interacting with our world. I think our knowledge in remote sensing science has always been a little bit ahead of our ability to deliver the full value of that science to end users. And as we keep innovating in this technology space, let's try to keep the problems we're trying to solve front and center.
That's fantastic. Thank you very much, Keely. And where can our viewers find out more about the Climate Corporation?
You can visit our website at climate.com.
Perfect. Thank you. Thank you very much, Keely, for your time today. It's been an absolute pleasure to have you on board. And if you'd like to find out more about UP42, you can also visit us on up42.com. Again, thank you very much, Dr. Keely Roth.
Thanks, Tom.